But that's going to do. I did something.
I'll translate that. That means he messed with it, kept changing stuff until it finally worked, and now he's not. All right. All right. So let's, we on? We're on. All right. So write a function named base to decimal. Takes a string as a parameter, representation of number and the base that that number is in. Should return the decimal equivalent to that number. And then I gave you some examples. So let's start off by translating this into a function header. So it's called base to decimal. Did I rewrite that part? No. So we're going to say we're ultimately going to be returning an integer, right? It's going to be called base to decimal. And we're going to take in a string. Let's call it value. And then an int base. I think I did write it last time. I must have just deleted it because I remember saying that in oh, actually, no, I did it up here where the mathematical term for this is radix, R-A-D-I-X. All right, so this is the dude we're going to write, base to decimal. So I prototyped it up top. I'll go ahead and scroll down here. We'll paste that guy there. Now, before we just start writing it, we want to remind ourselves the problem we're trying to solve, right? Okay, again, always understand the problem before you just start randomly writing code. So let's return to our slides and let's give ourselves a reminder of this. So we'll use this first example, the 101. So as an example, 101 from binary to decimal. That's what we're doing, right? In this particular example, base to decimal. In this case, we would be calling our base to decimal, passing it 101 and passing it 2. That's the base it's currently in, is base 2. All right. So now we want to remember our pattern. How do we convert between some base and decimal? Well, this is the one where we write out our number. And this guy is, this is the 4's place. This is the 2's place. This is the 1's place. We always start off at the 1's place on the far right. And then we multiply it by whatever base we're in as we move left. So this is 1 times 2, which is the 2's place. 2 times 2, which is the 4's place. So on and so forth. Make sense? Okay. So now we're going to just do the math. So this is going to be 4 times 1 plus 2 times 0 plus 1 times 1, which is going to be a 5. All right, make some sense? All right, so that's the pattern we're trying to mimic. Now we could remember in the back of our head that once we get to bases above 10, we're going to have to do that little mappy thing to figure out like, well, if I'm looking at an A, I actually need to treat that as a 10 before I start doing mathy stuff with it. So for example, if we have something like BAD from base 16 to decimal, from hex to decimal, we would write that. So this would be calling our base to decimal, passing it a BAD and passing it a 16. We're advertising what base it's currently in. We know we're converting it to decimal. We know our destination is decimal. Okay, but we need to know this is the current value and this is the base that current value is in. All right, so that's the call we would make for this. Well, we'll follow that same pattern. So we have B, A, D. We know this guy's is the 1's place. The times 16 is the 16's place. Times 16 is what, 256? No, that can't be right. Squared. 256. That's 16. That's the one. So again, our far right position is the ones place. Times 16 is the 16's place. Times 16 is the 256 place. Okay, we're starting to see our pattern here. Now we need to remember a couple of different things as we're looking at this. We want to remember, how do we solve problems? We use our memory, ask questions, repetition. So what things are we having to remember here? Well, we need to know the original number. We have that as one of the parameters coming in. We need to know what base it's currently in. That's also going to be housed in one of the parameters that's coming in. So we're already remembering those two things. Now, I probably need to remember this dude as he changes along the way, right? So maybe I call this place. So maybe we start off as place is equal to 1, and then he changes as we go. So I'm going to remember one additional piece of information at least. Okay. Now, when we did the math here, what did I do? I said 256 times, well, we needed to convert that B, right? Okay, but this is going to be times 11 in this case, plus 16 times, we need to convert that A, so that's a 10. So we're going to have to think about how do I do that conversion thing in a second. We'll write that tool. All right. And then we'll have a 1 times a D is a 13. And this should be 2989 when we put all that together. All right. So we're doing a whole bunch of summing here, right? So maybe this is another value called sum that we're going to remember. Make sense? Because we're going to be, as we walk through this, we're going to be saying what sum is equal to sum plus 1 times 13. So we're going to need to keep our running total as we go. So maybe a variable named sum to hold our running total. All right. So couple of additional things we need to remember other than the value in the base. We need to know what place we're currently in, and we need to have our running total for the value we're summing up. Make some sense? All right. So let's go ahead and give ourselves those variables as a starting point. So I'm going to go ahead and say int place here. And we know that place always starts off as a 1, right? That far right position. I need to make sure I start off at the far right position, right? But that will always be the 1's place, regardless of what base, because whatever base it is, that's the 2 to the 0th power place. And any value to the 0th power is a 1. So that's the 1's place. And what I mean by that is this is 16 to the 0, 16 to the 1, 16 to the 2. 2 to the 0, 2 to the 1, 2 to the 2. All right, that's if you wanted to put it in exponent form. All right, so we're going to start place off at 1. And then it's going to build by jumping times base each time. And then we're going to also start a sum off. And usually when we're adding a bunch of stuff together, we choose a base of 0. We haven't added anything to it yet. So right now it's starting off at 0. Make sense? All right. So now I have my stuff that I'm looking at. Okay. So now we need to write our loop. So again, we're using, how do we solve problems? Memory, asking questions, repetition. So now we're going to need some repetition. We want to start off at the end of our string and walk towards the beginning of our string. Make sense? That way we're looking at the 1's place first, then in this case, the 2's place and the 4's place, so on and so forth. Start at the end, walk towards the beginning. All right. So we're going to write a for loop. And we want to start off at the last legal position in our string called value here. Now, how many characters in value? Tell me precisely how I describe the number of characters that are in value here. Good. Yep. There's value.length number of characters in value. Right? We're writing our functions generically. Somebody's going to call this guy. He's going to pass some value in. He's going to pass some base in. And value.length is the number of characters in this string. If they pass in the string hello, that'll be a 5. If they pass in the string elephant, that'll be an 8, so on and so forth. Okay. Yes, I counted the number of characters in elephant that fast. I've never used that as an example before. Who wouldn't be? Okay, it's like the, special skills we have, know how many letters are in elephant, repeat the entire Greek alphabet. You all know the Greek alphabet. You do, beginning to end. Hit it. Yeah, that's really good. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, omicron, pi, rho, sigma, tau, epsilon, phi, chi, psi, omega. You're the first student that I think I've ever had that could do that.
I think I missed stuff.
You said it right. You just pronounced it a little funky. Oh, you may have even pronounced it correctly. You just pronounced it differently than I did. George, when did you learn that? Or was it just like a hobby thing, or was for? Oh, it was for a Greek class. Yeah, see, this was back before they let you, well, when they still let you do crazy stuff like this in school. I learned that, I want to say no, it was an English class. Yeah, for no good reason. I had a crazy teacher, and the competition was how many times you could say the Greek alphabet on a burning lit match. Yeah, in class, we're holding a match until it burns you. Yeah, that was back when they used to be able to hit you in school too. I have memories in first grade of Miss Mullinex, my teacher, walking me down the hall to the little closet on the left-hand side with a single pull string light bulb, and then beating the crap out of me with the stick hanging on the wall. That was a discipline problem. No, because it happened. I think it happened 3 times in first grade. And one of the times was just because I needed the snack, so I ate my crayons.
Hey, that's fair.
Hey, I was a problem solver even back then. I was hungry. People aren't bringing little juice boxes and stuff to school back then, right? So what I had available was crayons. Oh, and she loved it too. We had another guy in class. His name is Steve Scott, and I don't even remember what he did, but he did something that was, beating worthy, right? And quote in class, she's like, "Steve, I've been waiting to do this for a long time." That's this type of stuff that make TikTok today, right? This happened. This teacher wasn't canceled or anything. I think she got teacher of the year that year.
I'm like, how do you go from broad to like elementary?
Yeah. I ran into that teacher years later, because this is like a relatively small town. I ran into her at the chiropractor in town. I was no longer a first grader. I think I was in college at the time. So, and before I broke my back, I played Division I tennis in college, and I was 6'5", 230, like fit, a little bit different body type than now, but yeah, she was this little tiny woman. Tables have turned. Yeah, it was always my parents loved her. Man, somebody needs to beat Michael. It's not working at home. My dad was a dentist. We one time had a cop friend of the family call him at work because my brother and I were on the roof. We're like 8-year-olds running around the roof of the house. Yeah, we were problems. All right. I don't even know how I got onto that. How did I get onto beatings? What was
We're talking about
The alphabet.
Greek alphabet. That's right. All right. So I asked the question. Let's rewind 4 minutes or probably longer. I said, how many characters are in value? And you told me it's value.length number of characters. And that's correct. That's how we generically express however many characters are in that string. Because we don't know. We don't know who's going to pass this string in and what they're going to give us. we have to operate generically. Okay, so now what is the last legal position inside of value? That's the first legal position is 0. What's the last legal position? Yeah. So if this is our string, this has a length of 3, right? There's 3 characters inside that string. This is bucket 0, bucket 1, bucket 2. It's the length minus 1. So we actually don't want to start at value.length. We want to start at value.length minus 1. Because we want to be looking at the last legal character up there, right? And we want to work towards the beginning of our string. So we want to keep going as long as I is greater than or equal to 0, which is the first legal position in our string. And each time through, we want to decrement I. So we want to go from bucket 2 to bucket 1 to bucket 0, including bucket 0. That's why we say greater than or equal to 0. So we want to make sure that we are operating on bucket 0 as well. All right, so this loop takes I on a voyage from the end of our string towards the beginning of our string. We got to decide what we're going to do along that trip, what we're going to do on that voyage. So now we need to start thinking about stuff. Our place is already starting off at 1. So if I'm currently sitting here at the end of my string and I'm in the ones place, I want to take this number times the numeric version of this number and add it on to my running total, which is sum. Okay. So now we have our first quandary. How do I get the integer version of that value? Well, you could. We could probably have a couple different ways of pulling this off. So right now, if I'm looking at this, just breaking it down, I have, since this is, what did I call that, value? This is value at bucket 2. So value at bucket 2 is equal to the char 1. Place is currently equal to the number 1. I need to multiply place by the numeric version of this guy to give me the number 1. So right off the bat, I have a slight little problem. As a human being, I can look at this and say, look, this is going to turn into the number 1. I need to ask myself, how do I do that? How do I tell the computer to do that mapping or whatever? So how do I turn the char 1 into the number 1? I'm sure there's a conversion thing built into the language, but have we looked at it? Nope. So if we don't, go ahead. Mm-hmm. Yeah. Well, sure. So what's wrong with using index of? Isn't that exactly what we need?
Yeah.
If I wrote some sort of function, right, that I could pass a char to, and it returns the numeric version, which in our case, index of, if I happen, so what he's saying is, let's just write the function real quick. We already have a function here called index of that takes in some string, and what he's saying is he passed in the entire alphabet, 0 through 9, and then A through Z, right? So he passed in that particular string, along with the character he's looking for. So in this case, you were looking for the character 1. And you're asking it, tell me what position in this giant string you found a 1. Well, at bucket 0, I found a 0. At bucket 1, I found the char 1. Ding, 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 ding. So I'm going to return a 1. All right. So he used index of generically by passing it a big map string and the character he's looking for. And this returned the numeric equivalent. All right. Now, if we want to write this a little bit more hard-coded for this particular problem we're solving, I mean, that's the perfect solution, really. We already had a tool laying there. He's like, oh, well, could I use this in a specific way to solve this problem? Absolutely. So maybe we decide we're going to go ahead and just write a function with a name that kind of dictates what it's going to do. We're going to say this is going to be int char to int, And this guy will take in a char C as a parameter. Okay. And the goal of this guy would be to return the integer version of a character. Make sense? So we'll go ahead and write this guy. Now, we could write this guy as basically a duplicate of this guy down here, or we can just say, I'm going to return index of oh, do I? Oh, if I just press haha, ninja. All right, and along with a C. So I can just call upon my index of, passing it my super secret string and the character I'm looking for, and this guy will do the magic for me. So really, oh, don't leave this side. So really, I didn't have to write another placeholder here for me, but this kind of adds to the idea here that we're passing a very specific string in here. A string where 0 is at position 0, a 1 is at position 1, an A is at position 10, an F is at position 15, so on and so forth. Okay, so we picked a very specific string to pull this off. So up here, what I can do is I can say sum is equal to whatever sum is currently equal to plus, and now I need to do my math. So I'm going to take whatever the current place is, and I'm going to multiply it by, now the value I'm going to be operating on is value at bucket I, but this guy is a char. Okay, he's not a number yet. Now, if I didn't convert it, it's not going to scream at me. Why not? Can I say it's chars are numbers? Remember, chars are signed, or I'm sorry, chars are unsigned 8-bit values. So even though it's not the math we want to do, C++ is pretty cool with us saying, oh, we're going to take this int and we're going to multiply it by a char, and we're just going to give you a math answer based on the ASCII value of this char. That's not the guy we want. We don't want to know where that character lives on the ASCII table. We want to know what's the integer equivalent. If I'm looking at the char 1, I want to squeeze a number 1 out of that. If I'm looking at the char A, I want to squeeze the number 10 out of that, so on and so forth, right? And we just gave ourselves a tool to do that. So I can call my char to int that we wrote. Now there probably is something built into the language. I'm probably thinking A2I, if I remember correctly. A2I in C++ will convert a char to an integer. But doesn't matter. We didn't have to go and search for that. We'll just write our own. This isn't a big deal. I mean, it's a little tiny kind of puzzle, little problem. But this is kind of where I want your mindset to be going when you're writing these solutions to things. You know, we're solving stuff in terms of what we've already done in class. So if you find yourself asking the question, I wonder if C++ has a function that does, if you don't already know about it, it might be academically interesting to go and look it up, but you can't use it. So you got to write your own. So you're going to spend quite a bit of your time writing little tiny helper functions that don't do tons and tons of things, but they automate something that we needed to automate. In this case, I need to convert a character to an int. So I'm going to call my char to int function, and I'm going to pass it the char I need to convert. So char to int, passing it this character will give me the numeric value of that character, because that's what this dude does. It tells me where it found that character in this string. A 0 is found at a 0, a 1 is found at bucket 1, an A is found at bucket 10, an F is found at bucket 15, so on and so forth. And this guy is written in terms of my index of, which just loops through every character in there and says, did we have a match? Did I find the guy I'm looking for? If I did, I'm going to return where I found it, the position where I found it. So we wrote this in terms of index of, or like you said, you could have just called index of directly if you wanted to. All right, so we're going to add to our sum. So sum is going to become equal to whatever it's currently equal to plus place times the integer version of the character we're currently looking at. Make sense? And we're going to do that for every single character in our string. We got to remember though, after we've dealt with the ones place, I need to update place to be equal to whatever it used to be times whatever base we're currently working with. If it was base 2, it'll be place times 2. If it was base 16, it'll be place times 16. So it's going to be place times base, whatever base we are currently operating in. And again, we're writing this generically because we don't know what values are going to be passed in here by whoever calls our function. So we have to write our solution generically. Make some sense? And then when all is said and done, we're supposed to return an int. So after we've gone through every character in the string, adjusting our sum each time, adjusting our place each time, we can return sum when we're done. And now base to decimal should do what it's supposed to do. Go ahead.
I did a little funkier of a way that makes sense to me, I guess. Where for each place, starting in the right, going left, I would call a function that would calculate the exponent to the power. For the first time, it would be 10 to 0, and that would be 10 to the 1.
Oh, I got you. Yeah. So, yeah, and that's ultimately that is what it does. So what you did is you effectively say, hey, you know what? I might need a tool that calculates exponents, right?
Yeah.
Later on. In this case, we just happen to know that it's going to be the ones place times the base, times the base, times the base, times the base as we walk. So we can skip that. But what he said is, you know what? Maybe I want to, I'm at Home Depot. There's a big sale, right? I might want to calculate something to the power, which is built into the language in a math library or something, but hey, why not write it yourself? So he said, you know what, let's go ahead and I'm going to say int, maybe you called it raised to power. All right, so he wrote a function called raised to power, and he took base val and power as parameters there, or whatever he named them. He needed to know what's the number and what's the power I'm raising it to. Okay. All right. And we needed to go ahead and kind of have a number to build this up in. So we're going to go ahead and say int, I will say int answer, and we'll start that off as a 1. Then we're going to have a for loop that goes through power number of times. So for int I is equal to 0, I is less than power, I plus plus. All right, so he went through power number of times, and what does he want to do each time? He wants to say answer is equal to answer times base val. Does that power number of times, in the end returns answer. And remember, if power was 0, answer is a 1 because we started off. We won't go through this loop at all because it's a pre-check loop. For loops and while loops, we check this Boolean expression before we ever execute the body of the loop. What's a Boolean expression again? Any expression that boils down to a single value of true or false. So since if power was 0 is the current value of I, which is 0, is that less than 0? Is 0 less than 0? It's not. It's equal to it, but it's not less than it. So this fails the very first time through. So we never do this. Instead, we just drop down and return answer, which was a 1, which happens to be base val to the 0th power. So now we can use this function for whatever we want. It doesn't have to be related to the problem we're solving right now. We now have a little function that I can pass a number to, and the power I want to take it to, I can say 8 to the 13th power. I can pass in an 8, I can pass in a 13. It gives me back my answer, and that's 8 to the 13th power for whatever I want that for. All right, makes sense? sale at Home Depot. Okay. Buy one, get one. So I picked up the char to int because I needed that immediately. And you know, as an aside, I have a raise to power function now in case I need that at some point. But effectively, we don't need to actually do the raise to power here. Because in our function, this does take it to the next appropriate power. 2 to the third power is 2 times 2 times 2, right? In this case, we have the ones place times 2 is the twos place, times 2 is the fours place, times 2 is the eights place. So we know exactly what my next value is, so we can just multiply it through as we keep going. All right, so this should be base to decimal. We'll try it on a couple of our so in our samples that I gave for the homework, we have 101 to base 2. And then we have BAD that's currently in base 16. And there's our conversions. So that's the whole dealio right here, with the secret sauce maybe being this dude right here. What's up?
I said one, so could you technically do put value dot length in the -1 in parentheses and then put a space? I think I tried that. And it didn't work. I don't remember exactly, but I ended up setting.
What did you want to do here?
The value dot length -1.
Yeah.
I didn't build up the -1 right next to it, so I tried putting it in parentheses with a space between it or something,
You did that?
and then in parentheses.
Which part's in parentheses?
Value dot length of the -1.
Oh, so this whole thing's in parentheses? Yeah, that'll work fine.
Okay. For some reason I must have been wrong, so I ended up putting that in a variable instead.
Oh, I wonder if you like did something like that. Even that should work. I mean, it's funky, but it should work.
It could have also been that it's not a good day.
Oh, yeah. My guess it was a typo, forgot a semicolon or something along those lines. Yeah. Just like C++ doesn't care if you write your whole program in one line, it also doesn't care if you have spaces between known tokens like that. Because it's going to treat this guy as a function call. How do you think C++ knows that's a function? If you're at the zoo and you're looking at all the different animals there, how do you tell the zebras from the giraffes? You look for the the telltale signs of a giraffe, right? Right off the bat, you're looking for a long neck, right? That kind of stuff. So in the computer world, you're trying to identify the various actors that are on the stage, right? We have variables, we have numeric literals, we have string literals, we have functions. How do we know this guy's a function? What are the telltale signs of this guy being a function? Good. Yeah, those little parentheses there at the end. Okay. So at the very least, once we get a little farther, it could be another kind of animal, but it's going to be a function of some type. But right now, this is all we know about. We see the parentheses. We must be calling a function. All right. So, and who does that function belong to? It belongs to this thing value. Value is of type string. So this is strings length function. So this guy boils down to the number that is the length of that string. So that's going to be a numeric literal. Then C++ already knows about that guy. He's an operator. He's built into the language. So he knows about minus signs. Here's the number 1, numeric literal, built into the language. The number 1 exists, so it's going to know that that's a 1. And then it's just going to do the math. The length of this minus 1. See, doesn't matter if you put, a bunch of spaces here and 1 space here. All right, other questions? Go ahead.
You're coding. Yes, and it's kind of hard to know what exactly finish. Like how do you have like a strategy?
Well, yeah, I mean, and that's how we started here. We started on the slides. We said, if we want to convert this string from binary to decimal, that's going to look like a call to our function like this. So if our function was called with this string and this base, we spelled out what things we need to do. We wrote it by hand first. We said, this is how we solve this problem as a human being. Yeah, that's what we did right here. Yeah, we made sure we understood the problem. Then we asked ourselves, well, what things do we need to remember? Okay. We said we needed to remember what the place was. Let's see, where's my or maybe I deleted it on that thing. We needed to know the sum and we needed to know the place. So we're keeping track of those couple of pieces of information along the way. So that was 2 additional things we need to remember. So we wrote variables for those guys. If you remember, the very first thing we did is we wrote these 2 lines. 2 additional things we need to remember. So really remembering 4 things here. We need to know what value we converting, what base is it currently in. We're going to go ahead and give ourselves a value for our place, because that's something else that's going to be changing along the way. We need to remember it. And we're going to give ourselves the sum. That's something we're adding up. These are the tools that we're going to need to solve the problem in the way that we've proved to ourselves we understand how to solve here. Then we said, oh, well, we need to start at the end of our string and work towards the beginning of our string. So that's the next ninja move we need to do. So we went back to our code here. We said, okay, I'm going to write a loop that starts at the end of the string and goes towards the beginning of the string, including the beginning, stepping down by 1 each time. Okay, what do I need to do each time along the way? Go back here. Well, I'm going to take whatever the value is in this place, and I'm going to multiply it by the current place it's in. And I'm going to add it on to my running total, my sum. Because that's how you do this math. It's 1 times 1 plus 2 times 0 plus 4 times 1. As we walk towards the beginning of our string here, we're going to keep a running total of this number times this number, plus this number times this number, plus this number times this number. So we had to go back to our code here. We had to say, okay, I need to set sum equal to whatever sum currently is equal to plus the current place times the integer version of the value I'm looking at. Add to my sum, place times the integer version of that value, because this value actually looks like that, the char 1. So I needed to convert that to a 1. 1 times 1 is 1. Add that on to my running total, my sum. Then what do? I need to change place. Place started off as 1. Now it's a 2 because I'm dealing with base 2. So I multiply place times whatever the base is, and I set the new value of place to be that value. Do this over and over and over again until I've dealt with everything in my string. Ultimately, my answer is my running total sum. Spits it back out. So I write it down first, make sure I understand it, then I go through one kind of step at a time and write the code that's equivalent to that. Eventually, for problems of this size, you'll be able to do, something like this. You probably wouldn't have to write down once you've done this enough times. It's small enough where you can kind of capture the problem in your head without having to visually give yourself stuff. But until it becomes boring, writing it by hand and then translating that to code, write it by hand and then translate it to code. You're doing yourself a favor rather than kind of trying to keep everything juggled in your head, and you'll forget one thing you need to remember and that kind of stuff. If you wanted a little bit of a cadence to it, so maybe a programming strategy. And we kind of just did this, but you know, what all do I need to remember? Create variables for those things. Then what do I need to do? Actually, maybe I would ask the next question is, what will I ultimately return as my answer? Create a variable for keeping track of the answer. Let's say if that makes sense, but probably wouldn't hurt you to do that. What logic do I need to apply along the way to calculate my answer? This is the programming logic. So that's kind of the recipe for a generic function or something like that. Let's remember all the stuff I need to remember. Create spots, create variables to remember those things. Make sure I know what answer I'm coming up with and what kind of value it is. That way I'm able to advertise what kind of value I'm going to be returning, in this case, an int. And then what do I need to do in the middle to ultimately calculate that answer? Make some sense? All right, other questions? All right, so let's go on to something else here. Look at another practice type thing. Let's write a famous encryption algorithm. Okay, which sounds difficult, but we're going to pick a pretty easy one. We have something called the cipher CI. I think that's right. Caesar cipher is also known as ROT13. All right, so we're going to, and by the way, this is not a very secure encryption algorithm, but it worked for the Roman Empire to send messages, probably written in blood on parchment or something like that, from a couple places, as long as the recipients knew how to decode it. All right, so for example, if we take the string hello, I'm going to keep this all in lowercase just for our example here. And I want to pass this through ROT13, it's going to give me some answer. And what ROT13 says to do is it says for each char in a string, add 13 to it. Well, let's go. Let's write it a little differently. For each char in a string, move 13 characters later in the alphabet, wrapping around to the beginning if I run out of characters. All right, so to look at this guy, let me write out my alphabet. I have conveniently stored it right here. And we'll just assume everything's in lowercase in our example here. So don't make me retype that. I have an uppercase representation of a bunch of lowercase letters. In fact, here, we're going to assume everything's in uppercase. All right, so we're going to start by going to an H, and we're going to walk 13 characters later. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So an H becomes a U. An E, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And E becomes an R. L. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And L becomes a Y. We have two L's in a row. Then we have an O. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That guy becomes a B. You're the one who's got the Greek alphabet memorized. Urib. It's Urib. The double Y. I'm operating off my Klingon knowledge. You don't know Klingon, do you? All right. One up. I don't know Klingon. All right. One ups. There's the things that only work at the geek conventions. I think did I mention in here my dice made of asteroid? I was big into like tabletop Dungeons and Dragons when I was younger. I used to go to conventions. I was like one of the DMs at these conventions, and I brought my own dice and I had dice made of asteroid. They're little tiny things, but super heavy. Yeah. Well, yeah, it's like bragging rights, within a very specific community of people. You move outside of that community of people, you're a freak show. One time I tried to haggle at McDonald's with those dice. It did not work. All right. So that's ROT 13. I've now encrypted the word hello into Urib. All right. So now imagine that you're one of these Roman soldiers and you get this note that says Urib on it and like, oh, I need to convert this back. Right. All right. So I need to take a U and apply ROT 13 to it. Now, in your head, you might say, well, now I need to subtract 13, right? So here's my U. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's going to convert back to an H. Then we take an R. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's going to be an E. So on and so forth, right? We believe it's going to end up becoming hello. All right. But what's nice about ROT 13 is because there's exactly 26 characters in the alphabet, encoding and decoding mean the same thing. Let me show you what I mean by that. If I have U and I want to decode this, I'm going to move in the same direction as I did for encoding. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's my H. Okay. So the function for encoding and decoding a ROT 13 string is identical. Always add 13 with the wraparound. That's the kicker here. Okay, so we need to figure out how to do the wraparound. So we need to ask ourselves here, okay, what things do we need to remember? Well, I'm going to get as a parameter the string that I should be encrypting, right? But I'm going to need to keep track of my answer string as we go. All right, so I'm going to have to remember one additional thing at least. So we'll write a function up here and we're going to ask ourselves, well, what's my ultimate answer? What should this guy spit back? Well, he's going to give us a string, the encrypted value, right? All right, and we'll go ahead and call this guy ROT 13, stands for rotate 13. All right, and we'll take in our source string. So we'll create a string called source here. All right, so I prototyped it there at the top. Then we'll go ahead and write it here. All right. So I mentioned that we're going to need to have a string to hold our answer as we build that up. So we'll call this guy string answer, and we'll start him off at the empty string because we're going to be building him up as we convert character 0 of source to the ROT13 equivalent. I'm going to tack it on to answer, and answer needs to start off with a base of empty, but it still has to be a thing. So we did give an initial value of the empty string instead of just creating a memory location and putting nothing in there. So we're going to start it as the empty string so that we can build on top of it. All right. Now we go back to our code. We said, okay, well, what did we do? I walked through this string one character at a time, and I did the conversion on each character. So now I need some logic that will walk me through my string one character at a time from beginning to the end. So what kind of thing am I going to need to write? A loop, for loop probably. Okay. So we'll start a for loop. So maybe start int I equals, where do I want to start with? What position in the string do I want to begin with? Bucket 0. And I want to keep going as long as what's true. I want to go all the way up to the end of the string, including the last legal bucket in the string. What's the last legal bucket in the string? Length minus 1. The string's length minus 1. So I'm going to keep going as long as I is less than source.length. You could say I is less than or equal to source.length minus 1 if you wanted to, but I less than source.length gets us to the last legal character, including that position. Because that's not source.length is not a legal position in our string. Source.length minus 1 is the last legal position. And each time through, we want to take a single step forward to look at the next character. So this loop right now, as we have it written, takes an integer I on a voyage between 0 and source's length minus 1. I just happen to want to use that integer to grab characters at individual places in the string. So source at bucket I will give me the current character that I'm looking at in our string. But now I want to do something to this character. What do I want to do to this character? Add 13 to it. I want to take 13 steps through the alphabet, wrapping at the end of the alphabet back to the beginning when necessary. Okay. So we need to figure out, how do I do that? So that's the real question. Maybe we need to have our alphabet? I'm going to write it in all lowercase here. So we'll call this map again. All right, so there's my alphabet. But why? All right, there's my alphabet. So whatever character I'm currently looking at, I need to take 13 steps through my alphabet to get to the next character, or wrap to the beginning of the alphabet. How might you accomplish this? Okay, so the core, the go-to starting move, just in case, would be something like, so I can say something like source at position I plus 13, right? And he's hoping this didn't go off the end of this thing. So maybe you want to ask a question here. You want to say int pause is equal to I plus 13. And then, so we're remembering something, right? And then you want to ask the question. You want to say, well, if pause is greater than the end of the alphabet, So where would that put us at the end of the alphabet if it's greater than the end of the alphabet? Higher than 26? All right. 26 or higher than 25, because our alphabet, this is bucket 0, this is bucket 25, right? So if I'm at bucket 26 or greater, I'm off the end and I have a problem, right? Okay, so if I is greater than 25, that means I actually walked off the end of my alphabet. And if that's the case, what do I need to do?
Get the difference and then where to start beginning.
Okay, so how do I get the difference? So pause equals some value, and if I'm in here, pause is some value greater than 25. That's the only way I'm inside of that if statement.
The alphabet, length of string map,
That's good.
minus length of string map or 26.
Okay, well, we know it's 26. So you mentioned get the difference. Maybe that's something we're interested in. So maybe we say int diff, and we're going to set this guy to be whatever pause currently is minus 26. Okay, and that's going to tell us how far over we went, right? Okay, so if we know how far over we walked, that's what's stored in diff right now. It's how far over did we walk? Actually, do we want to do minus 25, right? Yeah, it is minus 26. All right, so this tells us how many steps over that we took. So now that I have that stored in diff, what am I actually going to set pause equal to? I'm adjusting pause. I took my initial stab at what I think pause should be, and then I said, oh, I went off the end. If I went off the end and I went off by this much, what should pause be now? Go ahead. Pause equals diff, or we could say pause equals 0 plus diff, because effectively we're going to start off at the beginning of the alphabet and then take a step in. All right. So one way or another, between this line and this line, pause is now pointing at the position inside of map where our mapped character is. Good. We're gonna wrap it with the modulus. Yeah, we're gonna do that. But not yet. We'll do it with questions and stuff first. All right, so now we know where in our string the conversion is. So we know it's map at bucket pause is our converted value, right? And what do I want to do with that char? Where am I building up my solution?
Answer.
Inside my variable called answer. So I'm going to say answer is equal to answer concatenated with map at bucket pause. All right, and we're going to do that for every single character inside of source. When all is said and done, we're going to return our answer. All right, so let's test this dude out. So cout rot 13 of hello in all lowercase. Ooh. Oh, I got that dude. NOPQR. Didn't look like we have the right thing there. Where did we screw up? Well, let's walk through this. I'm looking at, go ahead. So let's walk through this. As an example here, source is currently equal to hello. That's what we passed in, right? This is this particular example we're looking at. Go ahead.
Yeah, but you are.
Well, what do you? Well, I calculated diff here, right? Then I've set pause to be equal to what diff is. So when I get right here and I use pause, that's using the potentially adjusted pause. All right, so we're operating on HELLO. Okay, now we should be able to reveal our problem the very first time through because we see already that this N is wrong, right? All right, so let's walk through our code and see what our code says to do. Well, we're going to start off by remembering answer. Answer is the empty string. We're going to go ahead and give ourselves the entire alphabet here. We're going to have a loop that goes through every character of source, starting with the very first character. We're going to start off pause at what? Pause is going to be equal to whatever I is plus 13. What's the problem? I is the position of the character we're looking at, not the position of that character in the alphabet. We want the position of the character in the alphabet. Right now, we know that our first character is an H, right? And H is what this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 7. it's 7. Position 7 in the alphabet, right? All right. But I'm looking at a 0 for pause or 0 for I. I is currently 0. I want to be dealing with a 7. How do I get the 7 from an H? Use the index of function. Okay, so my index of function, I can say pause is equal to index of passing it map and passing it source at bucket I. Index of took in our map and then the source are taking the other direction. Yep. So it takes in the string I want to look in and it takes in the character I'm looking for and it returns to me the position in that string where that dude lived. Okay. So I'm going to set pause equal to the position in string map where the character I'm currently looking at lives. So in this case, I'm looking up an H in this string. And I just happen to have written a function called index of that does that. Okay. So this is going to give me presumably an 8. Okay, is that what it said? 8 or 7, whatever it was. All right. And then I'm going to add a 13 to it. And the rest of our logic should work. Urib. All right. Now I want to make sure we're clear on the difference there. Before I was saying int pause is equal to, and let's just replace these things for our first example. This is the position of H. This is what map is. What I had originally was 0 plus 13 because I is currently equal to 0. This was my original math. Pause equals 0 plus 13. It was giving me the 13th character in the alphabet, which was N, right? Then the next time through was giving me the 14th character, then the 15th character, and the 16th character because I was going up by 1 each time. I does not tell us the location in our string where that character is found. I just tells us which character in our string we're currently interested in converting. All right, so this is the guy we need. We need to know where in this string did this guy live, and it's that position we want to add 13 to. Make sense? All right. So there's our Uribe. All right. And as I mentioned before, rot 13 is its own reverse. So I can call rot 13 on rot 13 of hello, and I should get hello. Kind of a waste of time. I can call rot 13 on rot 13 of rot 13, and then I get my Uribe again. Go ahead.
If you wanted to like write an actual sentence, be able to put space.
Well, if you put spaces, then what would we do? So he's saying, well, what if I change my string here? Let's just go back to normal rot 13. Yeah. So if you're Caesar and you're deciding, well, how do I encrypt my messages? What might you do with spaces? You could say, well, I'm going to return a space, or you can say maybe spaces are, I'm going to turn spaces into some other character. But yeah, it has to be something that's not part of the alphabet, because if it's part of the alphabet, then you're going to try to convert it. So some placeholder for a space. So we could just say ignore spaces and just keep them as is. So inside of rot 13, we might say if source at bucket I is equivalent to a space. If I'm currently looking at a space, then what do I want to do? I want to say answer is equal to answer concatenated with space. We'll just keep it. Otherwise, do the rest of my magical junk. So if it's a space, just keep it as a space. Otherwise, do our mapping. Okay, so if this else, I do. And now it'll throw an extra space in there. There's our Uribe space, blah, blah, blah. Well, I would think if we were operating at this, since this is obviously a derivative of Klingon, that last Q is like a hard K. Yeah, obviously.
Yeah.
Right. So this is Jabik. Yeah, it's more of a guttural. All right. So homework. And let me save this guy. And then share this guy. Homework. Given the current state of our code, modify rot 13 to use modulus, that's the percent symbol, right? To figure pause rather than using an if statement to wrap to the beginning of the alphabet. Submit a link to your code and the self. All right. For some of you, this is going to take a minute. For the rest of you who, first of all, don't be intimidated if you think you're spending 5 hours in your homework and you hear some classmates say it took them 3 minutes before lunch. Remember I said programming is like a sport. You have to put the reps in. And if just because you weren't the best person on the baseball team day one and there was some other superstar, doesn't mean that you're not the one who's going to get the Division I scholarship eventually. Make sense? So you're competing with yourself, not with your classmates. Some of you are going to spend a long time in this. Some of you might even show up and say, I couldn't figure it out. It's okay, but I want you to throw the reps at it and try to understand, let's call it the math trick to this one. Hey, I've been doing this for longer than you've been a thing, and I've seen plenty of students that sucked in 200 that ended up becoming $100,000 a year software engineers right out of school. All right. I will see everybody on what day is today? Tuesday. I'll see everybody on Thursday. I want to remember is that Thursday is our tech talk with Aurora WC, right? 6 o'clock. I assume it's the usual time, 6 to 8. Yep. I have to think about that. It'll be either that or the week after that. So ask me at the beginning of class on Thursday. If we do, I'll go over the slides and say what's important. Sound good? What's up?